Good morning, my name is Elena Doinikova. I am from the Laboratory of Computer Security Problems of the St. Petersburg Federal Research Center, and I present our research devoted to the selection of countermeasures against propagation of harmful information via Internet. Today, Internet allows accessing and propagation various information. Some of this information can be undesired for particular user or even harmful. This information can include annoying suggestions for lottery, a proposal request or order to commit suicide, data about production, transfer, sale or storage of child pornography, and others. Some information can be forbidden by legislative acts, others can be specified as undesired by a particular user. Today, parental control systems filter traffic based on security policies. Social media platforms provide protection from unwanted information for a child if the user has specified their age. This protection is also provided by some operating systems, such as iOS, by blocking access to the pages with such content. Again, user must specify the correct age. All existing tools for counteraction against harmful information can be divided on two groups: tools that implement protection against the harmful information on the user side, and tools that implement protection against the harmful information on the information systems side. All existing tools implement checking information and restricting access to a resource with harmful information. While today there are quite a large number of systems to respond to unwanted information and some well-established set of countermeasures, such as filtering, blocking access, and notification, existing systems are often limited with the above-mentioned approach based on one type of countermeasures, namely blocking access. The objectives of this research are classify countermeasures and to develop the models and technique for automated selection of optimal countermeasures to counteract unwanted or harmful information on the Internet, depending on the type of such information and characteristics and needs of the system under protection. To achieve this objective, we propose a set of interconnected models, including threat model, countermeasure model, and information object model, and countermeasure selection technique for protection against harmful information in Internet. We limit object with information object in Internet. We specify it via object size, type of information object, and harmful object class, where size can be small, medium, or large, type can be harmful or not, and class is a class of harmful information object that can incorporate the following classes: object containing data earlier forbidden by court's decision, object containing data earlier blocked by authorized bodies, object containing suggestion for gambling or lottery, object containing proposal, request, or order to commit suicide and describing suicide as a way to solve problems, and many others. The classes correspond to the possible threats if object is harmful. We understand the countermeasure as an action or tool for protection of object from information security threat, where information security threat is represented by harmful information. We specify it using the class of affected threats, implementation type, implementation agent, class of the information object, and complexity of implementation. The class of affected threats connects harmful information object and countermeasure, and includes object containing data earlier forbidden by court decision, object containing data earlier blocked by authorized bodies, and so on. Besides, this model includes class of the information object, small, medium, or large. Here you can see an example of such connection for threat of propagation of information about drugs. Countermeasures are different for small, medium, and large objects. Also, countermeasure model incorporates implementation agent. It can be browser, internet provider, parental controls, antivirus, mobile application, operation system. And implementation type, it can be manual or automated. Agent and implementation type connect countermeasure model with protected information system. And countermeasure cost is specified using complexity of countermeasure implementation that depends on implementation type and implementation and currently is specified by the experts. In this slide, you can see how cost calculation is practically implemented. Depending on size of information object, implementation agent, and implementation type, we can calculate cost weight. The proposed technique used single criteria optimization on the basis of introduced countermeasure selection index and allows selecting applicable and optimal countermeasures for the particular system from specific threats. The developed technique gets as input the harmful information objects, the threats relevant for this object, and the list of countermeasures specified using the developed models. The technique includes two main stages: selection of the applicable countermeasures considering the protected system information objects and threats characteristics, and selection of optimal countermeasures on the basis of integral countermeasure selection index. The developed technique was implemented using Java. For the experiment, the dataset containing 10 million objects of different size was collected. This dataset included different threads. Thus, 14% of information objects contained data earlier blocked by authorized bodies. 13% contained suggestion for gambling or lottery. 29% contained information related with suicide. 14% contains data on pornography. 26% contained related with drugs information. 14% contained information for childs from 18. Last 44% contained other information. The analysis of the countermeasure selection component results allowed obtaining the following statistics. The set of possible countermeasures included 7% of information objects. For that were selected 3 possible countermeasures, and 92% of information objects for which 4 possible countermeasures were suggested. Distribution of optimal countermeasures for the system modeled in the experiment shown that for 44% cases, the countermeasures implemented by antivirus filtering tools were selected. For 31% of information objects, the filtering in the browser were selected. For 23%, notification to the resource administrator where the information object is located were selected. And for less than 1%, filtering by parental control system were selected. In this research, we considered the challenge of counteraction against propagation of undesired for particular user or of harmful information via Internet. The models of counteraction process, including the threat model, countermeasure model, and information object model, were developed. The technique for automated selection of optimal countermeasures to counteract against such information using these developed models is proposed. The experiment demonstrated the possibility of their implementation and applicability of the developed technique for the selection of countermeasures. The technique can be applied in public control systems in the corporate segment as well as for personal use. Thank you for your attention. Please feel free to send any questions by the provided email.